Hello everyone. So this is a video regarding the use of Parseval's identity. In the yesterday video, I was discussing about the finding of the infinite summation of 1 by n square, and there we use the function fx is equal to x with defining interval from minus pi to pi. Then ultimately we obtained the result that it was pi square by 6. Okay, so you should also go through the videos how we can obtain this relation, that is Parseval's identity, starting from the expression of Fourier series, and after that we are using this Parseval's identity in finding some summation of some familiar infinite series like this one. Now we are going to find the summation of this 1 by n to the power 4. Okay, so uh, for this we have to start with the function fx is equal x square. Okay, which is a even function, and this is the interval. So I already mentioned yesterday that we, to get some specific summation, like for here 1 by n to the power 4, we have to start with this function. Okay, some Parseval's identity of some specific functions can lead to these required summations. Okay, so therefore we are going to use this function here. And so first we'll write down this Fourier series for this function. So if you find the Fourier series for this function with the coefficients a0, an, and bn, you will use those particular relations, that 1 by pi, those Euler coefficients, Euler relations for Fourier coefficients, minus pi to pi fx dx, then 1 by pi minus pi to pi fx cos nx dx. For this one, 1 by pi minus pi to pi fx sin nx dx. Then when you will use this expression fx a0 by 2 summation an cos nx plus summation bn sin nx. Okay, so here after using this relation to find this coefficient and putting back the value of those coefficients in the relation, we can find the Fourier series for this function. For all functions we normally use this technique. Okay, so now if you see, this is a even function. Okay, for even function we know that coefficient bn becomes 0. We need not to find this coefficient. And if you find the coefficients a0 and an, then ultimately you will find the Fourier series. I will write down the final Fourier series expression here. It will be pi square by 3 plus summation 4 1 to the power minus 1 to the power n square. Then here it will be cos nx. Okay, so since it is a even function, we are only having the cosine series along with one DC component. So here this is the value, and okay, so here this is the value of an, and this is the value of pi square 3. This is the value of a0 by 2. This is not the value of only a0, remember, this is the value of a0 by 2. Okay, so from this we have now obtained the value of a0 and an. It will be 2 pi square by 3, and this is the value of an 4 minus 1 to the power n square. This is the value of an. Okay, when you find the use this relation to find the an for this function, this value you will obtain. I have written down the expression of Fourier series just to show you. Okay, so while doing the problem, this Fourier series you need not to write. Whenever you will find the coefficient an and a0, then you can proceed to use the Parseval's identity, because in the Parseval's identity only those coefficients are required, and for even function we know that bn is 0 and we need not to find the coefficient bn. Okay, so now we are going to use the Parseval's identity and we will put this coefficients value there. Okay, so since here we have written the uh, this function is given in terms of the variable angle, then we will write down the Parseval's identity where this limit was given from minus pi to pi, that one, fx square dx pi a naught square by 2. Since it is a even function, we will write only the coefficient an. Okay, another coefficient bn will be 0, that I have already mentioned. So this will be 1. Okay, so after that we'll put this value of this function. It will be minus pi to pi x square dx, then sorry, it will be x to the power 4, because function is given, function is x square. It will be x to the power 4 dx pi a naught or okay, a naught we have obtained 2 pi square by 3, so 1 by 2 this will be there, then 4 pi to the power 4 9. Okay, plus summation, we have to square this value, the coefficient an, then it will become n to the power 4 16, then it will become, if you square then twice n will come, then means it will be 1. Okay, so after that it will become x to the power 5 pi minus pi 9 2 pi to the power 4 plus 16, we can take outside of that summation, 1 by n to the power 4. Okay, 1 to infinity, then it will become pi to the power 5 plus pi to the power 5 plus divided by 5. So negative, this minus and minus sign will become plus here. So after that this will become 2 pi to the power 4 9 into 16 summation 1 to the power n to the power 4 1. Okay, so after that it will become 2 pi to the power 5 into 5 pi 16 summation 1 to infinity n to the power 4. So 1 pi get cancelled, so it will become 2 pi to the power 4 5. So if we take this thing in the left hand side, it will become 9 2 pi to the power 4 16 summation 1 to infinity 1 divided by n to the power 4. We can take 45 18 pi to the power 4 10 pi to the power 4 16 summation okay. So if we can take this thing in the left hand side, 1 n to the power 4 1 to infinity, so 45 this will become 8 pi to the power 4. So if we take this thing to this side, it will come to the denominator 16. Okay, so 8 2 then pi to the power 4 90. Okay, so we have obtained that the value of this infinite summation 1 to infinity pi to the power 4 90. Okay, so this value you sometimes you have to use in many cases, so this value you have to remember. Okay, so similarly uh, we can also obtain the value